Okay, grade 11s, we are simplifying the following expressions. We'll deal with the first one, 2.1.1. As soon as you see that there's certain ideas you must already have. So you see all of our bases are different, right? So that already gives you an idea. You want to have same bases, okay? So the first thing that we're going to do, maybe step one for you, is to make prime bases. Also notice that there's only one term on top, one term at the bottom, right? So if it was something where there was two terms on top, two terms at the bottom, you would generally end up factorizing. But for us, for now, we only see one term on top, one term at the bottom. So it's going to be easy. We're going to follow the same steps. The steps we're going to do is get prime bases. Then we'll get rid of our brackets. We'll see there's going to be brackets formed. And then the last step is to use the first and second exponential laws to simplify, right? So let's go through that. So the 15 over there, we are going to change that to a prime base. So that's going to be 3 times 5, right? So let's go 3 times 5. 3 times 5 is still 15. Okay, we're going to put this in brackets. The reason the brackets are important, because we remember our, I think it's like a third exponential law that tells us the exponent outside multiplies with all bases inside, right? Or rather all exponents inside. So we know there's an invisible one there. Both of these need to multiply with this exponent outside. Okay, so that's why the brackets are important for us. Okay, let's move on. That's the 15. We replace it with 3 times 5, the 9. We're going to replace that with 3 squared. Okay, remember to put this in brackets. Our exponent outside is 3 to the power of n. Is that a minus 1? Great. 25, that's going to be 5 squared. And on the outside, we have n as an exponent. All right, so that's going to be a n. Let's maybe just rewrite this a little bit nicer. Okay, that is 5 to the power of 2 inside our bracket. Great. Here's our denominator 45. Sometimes maybe we can't figure it out. Sometimes there's values we maybe don't know how to get as prime bases. So take the 45, right? Go to your calculator, you press 45, you press the equal sign. Then you press your shift button or your second function button, whatever your calculator has, and you press the factor button. Okay, go look for the button that says fact, and that breaks up your value, your 45, whatever your number is going to be, into prime bases. So what we found is that 45 is 3 squared times 5, right? So the calculator does that for you. And again in brackets, and we have 2n outside our bracket. 27, we know that is going to be 3 cubed. That was easy enough. And we have the n minus 1 there. And lastly, 5 to the power of n, well, that will just stay the same. Great. So again, what we said was step one. Step one was to make all of our bases prime bases. Step two, we said get rid of our brackets. Okay, so as we've mentioned, this n plus 1 as our exponent over here. Let's put this over here, this n plus 1, that is going to multiply with that one as well as with that one. So let's see what we get. We will have 3 to the power of n plus 1 and plus 1, as well as 5 to the power of n plus 1. Right, similarly over here, this 2 is going to multiply with our 3n, as well as that 2 multiplying with that 1 over there. So we will have 3 to the power of 6n and minus 2. Okay, 2 times n, so this is going to give us 5 to the power of 2n. Okay, let's check the denominator. Okay, so this is going to be 3 to the power of, so this 2 multiplies with that 2, gives us 4n, and this 1 invisible 1 multiplies with the 2n, so that's 5 to the power of 2n. Then we're going to have 3 to the power of 3n, and 3 multiplies with that negative 1, gives us negative 3, and the 5 to the power of n stays there. Great. Next, right. So now what we've done is we've gotten rid of all our brackets, and what we can see now is that there's one term on top, one term at the bottom. We can now apply our first and second exponential laws. So just to remind ourselves, first exponential law, when you have the same basis and you are multiplying, you add your exponents, right? So we're going to add this one and this one. Reminder, second exponential law, when you have same basis and you are dividing. So the threes at the bottom, these bases at the bottom, that's the same as the ones on top, they are dividing, so we are going to subtract the exponent. So that 4n and this entire exponent there, 3n minus 3, we are going to subtract those from the ones on top. Okay, let's see how this looks. So we will have, okay, a base 3, we have this n plus 1, that's this one, and now we're going to add the 6n minus 2, that's this one. Now we're going to look at the ones at the bottom. So this one over here, we are subtracting because it's at the bottom, 4n, and we are subtracting this one over here, which is going to be 3n minus 3. Now just remember that that needs to be in brackets. The reason that needs to be in brackets is because this negative is going to impact everything inside our bracket, right? So that 3n is going to become a negative 3n. This minus 3 is going to become a plus 3. So make sure you put that in brackets, okay? So we've dealt with all the bases 3. Great. Let's have a look at the bases 5. So here's a base 5. Here's a base 5. Both of them are on top, so they're multiplying, and we are going to again add our exponents there, and then we have a base 5 at the bottom and another base 5 at the bottom, so we'll subtract those exponents over there. Let's see how this looks. This will be 5 to the power of n plus 1 plus the 2n. Okay, so that came from there, and then we are looking at the one at the bottom, so we're going to subtract this one, minus 2n, and then we are going to subtract this one over here, which is minus n. The rest is just to simplify all of that. So let's see, this is going to be 3 to the power of, so this is going to be a n plus 6n, that's going to give us 7n, minus 4n, it's going to be 3n, and then minus this, so all of our n's are going to disappear. What we still have is our constant, so this is going to be a plus 1, minus 2, that's going to give you minus 1, and I remember this negative interacts with that one, so it's going to become positive 3. So let's do this again. Plus 1 minus 2 is going to give you minus 1. Minus 1 plus 3 is going to give you a 2. Okay, let's look at the base 5, and there's a n plus 2n, that's 3n, minus 2n, so that's 1n, minus this last n, n's all disappear, and you are left with 5 to the power of 1, and that can simplify. 3 squared is 9, 9 times 5 is 45, and that is your answer.